Algebra Half, Lesson 5. You can find it on pages 20 and 21 in your blue books. It's called Addition and Subtraction Word Problems. Word problems are no different from any other problem. We just need to build the operation from a situation or a story. In fact, it can be more fun because you can actually picture what you're working with, and it's not just strict numbers. So some people actually really like word problems, and I know some maybe don't. But I really need you open to page 20 in your Algebra Half book because I'm not going to have the word problems written out. So you're going to need to be following along. I'm going to give you about 10 seconds to make sure that book is open to page 20, Lesson 5, Addition and Subtraction Word Problems. All right, we're looking at example 5.1. Take a look. It starts the Duke. Okay, be ready to kind of read along with me. We're going to be finding patterns in our word problems so that we can be successful consistently solving them. The Duke counted 5,260 people, then the Duchess counted 4,720 people. How much greater was the Duke's count? All right, now you can watch my screen. We have the clue from the words how much greater that there is a pattern, and how much greater problems are typically subtraction. How much greater than is a subtraction pattern. We remember that the bottom number in a subtraction pattern is the difference, right? The answer to a subtraction problem. So whatever goes around here will be the difference. So if we're looking for how much greater than, we're looking for the difference. The greatest number is the minuend, which is the top number. So remember, this is the minuend. And that's the biggest number in a subtraction problem. It needs to be at the top or it won't work out. And the biggest number in this problem is 5,260. And remember, we're finding how much greater than. And that's going to be the difference between minuend and subtrahend. And that's going to be our answer down here. Lastly, the middle number is the middle amount. And we have 4,720 for a subtrahend. So it's just good to remember that any how much greater than problems are going to be a subtraction to solve. And in subtraction, you've always got a biggest number, a medium, and then the difference is always smallest because it's the difference between them, and it'll never be the same or nearly as much as the other two. So how much greater than the Duke's count, or how much greater than the Duchess's count would be the Duke's count? How much more is 5,260 than 4,720? And another way of saying it, what's the difference? 0 minus 0 is 0. 6 minus 2 is 4. 2 minus 7, can't do it. So I need to borrow from the 5, which becomes 4. So I take 10 from the 5, giving me 10 plus 2 is 12. Minus 7 is 5. This 4 minus 4 is 0. So my answer is 540. Looks about the same in the book. The Duke's count was 540 greater than the Duchess's count. All right, that's one pattern. Example 5.2 says 417 birds were in the trees at 8 o'clock. By 9 o'clock, the number had increased to 942 birds. How many birds arrived between those two times? This problem makes us think, well, we had some, and then we had some more. Some and some more problems will follow an addition pattern. One addend is known. We had 417 at 8. And then we know how many that we ended up with. The number by 9 had been totaled to 942. What's the answer in an addition problem? The sum. This is one addend. Do we know the other addend? If you're solving carefully, no, we do not. If you're solving carefully, you realize we had some. Then we had some more that gave us 942. We don't know how much that was. So the birds that arrived our letter B. But why don't we just solve for letter B? How do we solve for a missing number in an addition problem? Take the sum and minus the addend. We learned that last year. And that will give us the other addend. Use an inverse operation to solve. Again, we need to do some borrowing. You need to make sure you know this like the back of your hand in algebra half, or you'll have a lot of troubles. 525 is what I get for my other addend. And how could I check this? You could plug it in here and make sure it adds up. And it will. Example 5.3, at sunrise, many ducks were in the pond. Then 425 ducks flew away. 642 ducks remained. How many ducks were on the pond at sunrise? We had some went away. When something goes away, we have a subtraction, right? We take away problems, or when we have something go away. This problem says some ducks flew away. We don't know how many ducks there were to start. If you read carefully, at sunrise, we just know there were many. So we don't know how many that is, just many. Then we knew how many exactly did fly away, so let's take away from many, and then we know that what remained was 642. We could not solve without these two numbers. We need at least 2 out of the 3. Now, to solve for many, how do we solve? Are we missing the biggest number in a subtraction, the middle, or the smallest? The biggest. And it's going to need to be well bigger than this so that it can fit under here in the difference, even though I subtracted. So how do we solve for the biggest number in a subtraction problem? We actually have to add the other two numbers. And that will come out to 1,067. If you look at how they solved that on top of page 21, you can certainly pause and read and think and process this at your own pace. That's important to understand what we're doing here. Don't just sit and kind of laze away and let me talk and lull you to sleep. It doesn't help anyone. How could we check our answer? You take what you found, you plug it in for what you claim it is, the original amount, the many, and it will work. Finally, example 5.4 on page 21, right before the practice problems, it says George had $5.42. Then his mom gave him some money. That was nice of her. Now he has $9.65. What does this sound like? He's got some money, $5.42. Then he got some more, right? So what is this? It's addition. And we actually know the total, but we don't know the amount that he was given. Is that going to change how we solve? Yes. We need to use subtraction to solve. So take the biggest number, take away the addend we know, to find the addend that we don't. Plug it in here to make sure. And it once again does work. Why don't you have an excuse to get these wrong? You can always check and think it through. They are all very logical. It just doesn't always happen the first time if you don't take that step to think about it. Just think about the problem. Picture it. Even draw a picture if you need to. But we've explored the how much greater than problem, which follows a subtraction problem with big number, middle number, smallest number, solving for the missing. Then we talked about sum and some more, both when we're missing the middle addend and when we're missing the biggest addend. And finally, we had sum and sum went away, which again is a takeaway subtraction problem. We had it where we were missing the biggest number, so we had to add the rest. So inverse operations come into play here. Solve these word problems carefully. Pick A or B. Challenge yourself with B if you can. Show me that answer before you get to work on problems 1 through 30. Again, be very careful. Do your very best. No excuse for redos at this stage. You can do this. You can do it.